So for assignment 7, number 2, the most significant bit is the C bit, which is X and Y. An AND gate it's um, only has an output of 1 when both X and Y have an input, which corresponds to the truth table of the C gate. So for assignment 2, number 5, we were proving that you can't determine 3 unknown currents in a 2-loop circuit using 2 junction equations and a loop equation. So again, I made a math mistake, and going back through, um, you can see that I3 actually equals -1 minus I1 R1 all over R2, which is the same as you get from the first loop rule, which means that everything cancels. So you're essentially saying that 1 equals 1, and the answers become arbitrary. The answer for the different currents become arbitrary, and you can't determine the current values through these equations. On assignment 6, number 5, I made an error for segment E. I used De Morgan's theorem wrong. I needed to have it say not F2, not F1, not F0, not, and not F3, F2, F1, not F0, not. I forgot the 2 extra nots. Then for segment F, I simplified the equation using combining in the Carnot map to get not F2 and not F3 or F1 and F0. So this is the map of NAND gates for segment E. You have not F2 and not F1 and not F2, not F1 and not F0. Here's the and, the not. Then you have not F3 and F2, F1 and not F0, and not, and then and again. Then this is the NAND gates for segment F. I went from my more complicated equation. So I have not F3, not F2, and not F1, F0, and F0, and not. And I have not F3 and not F2, F1 and not F0, and not. Then not F3 and F2, and F1 and F0, not. And then all of those are knotted into one big NAND. For assignment 3, number 3, the connection to pin 13 is now on the opposite side of the capacitor when we switch the capacitor and the resistor. So rather than getting the low voltage that increases as the capacitor charges, pin 13 receives all 5 volts to start, which then reduces over time as the capacitor charges. Therefore, the light will take a shorter amount of time to turn on, and it will turn on almost immediately, then go off once the capacitor charges.